So today we're going to solve systems using tables and graphs. So let's start with tables here. So I'm just going to choose some x values here. I see a denominator of 2, so I'm going to pick some even numbers, maybe 2, 0, -2, -4. So just choose some x values you're going to plug in. And so we're going to plug it into this expression. So 2 times 3 halves is, let's see, 2 times 3 halves plus 4. So the 2's cancel. You get 3 plus 4 is 7. So 2 comma 7. Oh man, way up there. Somewhere around there. Let's see, 0 times 3 halves. 3 halves times 0 plus 4. And that's really going to be 0 plus 4, which is 4. So I get 0, 4 is this point right here. Plug in -2, so 3 halves times -2 plus 4 is, let's see, that's going to cancel but leave a negative behind. So I'll have -3 plus 4 is 1. So -2 comma 1, just like here. And this would be 3 halves times -4 plus 4. So that's going to cancel. I'll give you -2 times 3 is -6 plus 4 is -2. So -4, -2 is right there. And you can see these points, they all have the same slope. You can probably plot a few more. Plot that line. Pretty good. And let's try the other one here. So let's plug a few of these in. So we've got, let's plug in the same points. 2, 0, -2, -4. Let's see what happens. So if you plug in 2 here, we get -1/2 times 2 minus 4 is -1 minus 4 is -5. So I have 2 -5. That's right down here. And -1/2 times 0 minus 4. 0 minus 4 is -4. Let's see, 0, -4 is right here. And let's plug in -1/2 times -2 minus 4 is really +1 minus 4 is -3. So -2, -3. And -1/2 times -4 minus 4. That's +2 minus 4 is -2. Negative there. And so that'd be -2. And that looks like it hits on exactly the same point. So you can see that -4, -2, -4, -2. That's the same point. That's the solution to this graph. So I could continue. I could graph this. That's fine. That's the solution of the system. So when we do solutions of systems, I always want you to get in the habit of writing your answer as an ordered pair. The answer to this system is -4, comma, -2. You don't have to put x and y there. You just leave it as an ordered pair. That's really what we're finding graphically or algebraically or even in the table. We're finding the ordered pair that is the solution to that graph, that system really. So let's get your calculators out and let's learn how to graph on our calculator. So if you hit the home key on your calculator and then go to the graphing app right down here, you should get a graph. And so we're going to type in this one, 3 halves. So to type in 3 halves, hit Control Divide and type in 3 divided by 2 times x, which is at the bottom of the screen there, plus 4. And press Enter, and you get a graph there. And then hit Tab to open an entry line, or Control G, and then type in 3 halves x, -1/2 x, so Control Divide. And -1/2, -1/2. minus 4. And so that's the system we just graphed on paper. Now we just graphed in our calculator. There's a couple different ways to find the intersection points. One is under the menu command with Analyze Graph. And you go to intersection point, click a value below, click a value above, and it'll show you that point, -4, -2. I prefer this method. I hit the menu key and then geometry, points and lines, and I go to intersection points. And if you don't know how to use a tool, it'll tell you how to use a tool here. Click on the two graphs, basically. Click the red graph, click the blue graph, and it shows you the point of intersection there. It is -4, -2. So that's how you use your calculator to find point of intersection there. And I want to show one more thing on the calculator, which is the table. So when I have two functions in there, f1 and f2 are in there, if you hit Control T, so I'm hitting the T key at the bottom, you can't see it, but I hit Control T, it gives you a table, and you can scroll through the table and find out when those values are equal. They're not equal right now. What I mean by this column and this column should have the same values. Oh, I just see. Oh, I almost passed it. They almost had the same, but they didn't there. There it is. So you can see when x, this is x, is -4. The first function, the y value, is -2, and the second function, the y value, is -2. So this is the solution to the system using the table. So actually, this is outdated advice. You don't have to solve for y to graph in TI-Nspire. So to graph on your graph, it might be a good idea. But on TI-Nspire, we can actually graph these without solving for y. Let me try to grab this and move this over so I can see these two equations. Okay, so I'm going to hit the home key, go to a new graph. And I'm going to type in, so I'm going to hit the delete key. This is using a relation. Oh, I got to update my calculator. Let me start this. Okay, voila, I have an updated calculator. If I hit delete now, I get a choice of a relation. So when you have a relation, you can actually enter it as it looks there. So you can enter let's see, so this would be x minus, so x, where is x? I'm going to move this down so I can see it better. X minus 2y equals 4. And just press enter. Wow, graphs without solving for y. It's crazy. TI-Nspire is the best. 3x plus y equals 5. Press enter. It graphs. Again, my favorite way is go to geometry, points and lines, intersection points, click on this graph, click on this graph, and it gives you the point, which is 2, -1. That is the solution. That's how I want you to write your solution, and you got it. So using your TI-Nspire, we were able to graph that pretty easily and solve it. So I want to talk about classifying systems. And this one, there's two types of consistent. There's either independent or dependent. So first there are, you can classify by the number of solutions. So if you have at least one solution, it's consistent. It's inconsistent if your system has no solution. So think about it. If you had two parallel lines, you would have no solution here. So then there's two types of consistent systems. There's an independent, which has one solution, and then there's a dependent that has an infinite number of solutions. So let's look at see what kind this is. How many solutions does this one have? It looks like it has one solution. So if it has one solution, it must be both consistent and independent. So this is consistent and independent. This one doesn't look like it crosses at all. They look like parallel lines, so it has no solution, which means it must be inconsistent. And then coinciding lines, what that means is there's a line on top of another line, like there's another line on top of it. How many solutions would that have? Well, this would be a solution, this is a solution. There are so many solutions. There's an infinite number of solutions. So we say infinite solutions, which means this must be consistent and dependent. Consistent and dependent. So that's just type of systems that you have. Oftentimes you can classify without even graphing. So sometimes you can just look at it and think about the slope and the y-intercept and think about, so like looking at the slope, 1/3, same slope, different y-intercepts. That means these two lines are parallel, which means no solution, so it must be an inconsistent system. So this one is inconsistent. And classify these without graphing. So, this is a little tougher here. So you might want to consider solving these for y, right? So y equals 3x minus 4. So the slope is 3. Y-intercept's -4. If you solve this one for y, you get -1/3 y equals -x plus 1. Divide by a third, or maybe it'd be easier to multiply everything by -3. Multiply everything by -3. So that's there. So I get y equals positive 3x minus 3. So this is a positive 3, this is positive 3. They're different y-intercepts. So those must be in an inconsistent system, because there is no solution there. So here you can see that we have a slope of -2/3 and a slope of -4 when you solve them for y. So they're going to have different slopes, which means they would cross and have one solution, which again means one solution is consistent and independent. And finally here we have the same slope of 2 when you solve for y, and the same y-intercept of -3. So clearly that's the same exact line, which means same line is, has an infinite number of solutions, so it's both consistent and dependent would be the result for that one. And that's the end of the screencast.